Hello friends, in today's question, two bodies A and B of masses m and 2m respectively are placed on a smooth floor. They are connected by a spring. A third body C of mass m moves with velocity v0 along the line joining A and B and collides elastically with A as in figure. At a certain instant of time t0, after the collision, it is found that the instantaneous velocity of A and B are same. Further, at this instant, the compression of the spring is found to be x0. Determine the common velocity of A and B at time t0. And part B, the spring constant. So these are the three blocks A and B which are connected with the spring, and C is a block which is moving with the velocity of v0. Okay, and C has a mass m. A also has a mass m, whereas B has a mass of 2m. So it is given that initial velocity of C is v0. So you can say velocity of mass C is equal to v0, and it is also given that the collision between A and C is elastic. So you can say collision between mass C and A is elastic. So it means that mass A will acquire a velocity of v0. You can say mass A will acquire velocity v0. Okay. Now it is given that at a certain instant both A and B have the same velocity. Okay. We can say that at certain instant, we can say let, or we can say both A and B have same velocity, which is v. So according to the conservation of momentum, conservation of momentum, initial momentum, that is for block C, you can say our mv0 will be equal to one thing. Let us for the time being say that we are not going to consider v0, because it's here mentioned that after certain time t0 both velocity of A and B is same. Okay. So we are going to focus on this part. So let us ignore this thing. That was a mistake on my part. So we can say m is equal to mv0 will be equal to momentum of A plus twice m momentum of B. So this will be equal to thrice mv, and from m and m cancelled out, and we get that v will be equal to v0 by 3. So So this is the common velocity of A and B at time t0. So this is the common velocity of A and B at time t0. And then next we are going to find out the spring constant. Okay, and for that we are going to use the conservation of energy. Okay. So we can say, as per law of conservation of energy, we have initial energy that is of block C, which will equal half m v0 square is equal to energy of kinetic energy of rather block A. So that will be half m v square plus energy of block B, which is half 2m v square, and the extension spring is compression is found to be x0. So that comes as half k x0 square. So we can write this as half m v0 square is equal to, we get this as 3/4 m v square plus half k x0 square. And we already know value of v, that is v0/3. We substitute here, so we get half m v0 square is equal to 3/4 m. So this comes v0/3 whole square plus half k x0 square. And from here we can say that our half k x0 square is equal to half m v0 square minus, and this will be coming as 1/6 sorry, I think, yeah, my mistake, this is 2. Okay, 3/2. Yeah, I think now it's correct. So this will be coming as 3/9, and this comes as 1/6 m v0 square. So we can solve this further. So we get half k x0 square is equal to taking 6 as LCM, so this will 6, 3, this will be 1/3 m v0 square. So the spring constant K will be equal to 2/3, and this will be m v0 square divided by x0 square. So this is the spring constant. So this completes the question. Thank you.